Hello, welcome. Jay with Speed Density. Today we're going to be talking about our product, our 996 four-wheel drive controller. So let's jump in. So we have everything laid out here on the bench. I'll talk about this first. This is the 996 front differential assembly. Over here we have input and output. In a sense, the power is traveling this way. Touch more about those labels here in a second. Differential carrier is inside here. This is the driver's side front axle, passenger side front axle for output. So this right here is the original viscous coupler that sits in there like that. So power goes from left to right. And this thing is pretty inferior. When we were testing on it, that it actually only was able to transfer 10 foot-pounds of rolling torque. And today we're going to be showing how our four-wheel drive controller can transfer much more torque than that. So here we have everything laid out on the bench. Starting from the right side here, this is our four-wheel drive controller. We have it labeled input. We have this tool here to drive the input shaft, and the bottom here is the output, which you can't see. It's splined to this housing, so this whole housing in a sense is the output. So over here we have our power supply. This is the standalone control box. When we first released this product, you could only use it with a Motec or a Cyvex or an AEM standalone box that you could build your own map to vary the voltage and frequency to it. So this is a new product. We're just showing you how it works and doing some testing. So let's jump in. So what we're going to do here is turn on the unit. I'm going to turn on my power probe or my voltmeter. Sure it's on DC. All right, so what I'm going to do is I'm going to test this with no power applied to it. So we got 0 on the voltmeter. As you can see here, it's just reading 0 foot-pounds torque as I rotate it. So this is the adjustment knob here. So all the way counterclockwise is off. As you start rotating it clockwise, it starts applying power to the electromagnetic clutch, which is right here at the bottom, and it's have the voltmeter piggyback off of the output wires going to it. So let's start at 1.5 volts and measure that. So you can see it's about 15. So 15 foot-pounds. It's hard to read. There we go, 15 foot-pounds. What I'm going to do is I'm going to turn it up to 2.5. So we're at about 30, just a hair under 30. All right. Let's turn this up to 3.5. So it's starting to bounce now. Well, we're at that 40, just under that 40 foot-pound mark. Let me turn this up to about 5.5. So 5.47. It's like just under 50. Let's see if we can get a better reading. It's starting to bounce. So it just about rates a 50 and then it breaks loose. So if you do the math here, inside here is a 3.4 final drive ratio. So I have over here, if you do the math, 50 times 3.4, so we're at about 170 foot-pounds of torque going to the front wheels. That is a significant upgrade to this inferior centered viscous coupler. So I want to show you one last thing. This box actually has a cool feature. So it has this brown wire, and if you ground this brown wire, it cuts power. So you can hook this up to your e-brake switch. So if you want to do a slide, you basically ground this or pull your e-brake up, which grounds this. And if you really want to get tricky, another option you could do is a throttle stop. So if the car's idling, you'd have to fabricate a switch up. So it would ground this when the throttle is at 0, and then as soon as you touch the throttle, power goes back into that to the front wheels. So here, let me show you here. Let me ground this. There's the voltmeter, 0. I'm going to unground it. And then we got voltage again. So that's a wrap. So as you can see, this it is a significant upgrade to that viscous coupler. Thanks for watching, y'all.